In today's lesson, we are going to look at the second part of exponents. Now, this type of sums we're going to use, we are going to focus on using prime factorization as an initial step to simplify these type of sums. So the first example is quite simple, and here we actually don't even need to use prime factorization. What we see here, and you can actually do that with just basically using the laws of exponents. What we see here is all bases are 5, and we know when we multiply the same base, we add our exponents, and when we divide the same base, we subtract the exponents. So the first thing I'm going to do is just show you a way to do it in one step. So if we have the base of 5, we then look at the exponents at the top, we add them, so we've got x plus 2x, and then whenever exponent is at the bottom, you just simply subtract it, so that's minus 3x. Now simplify after that. X plus 2x is 3x, minus 3x is 0, so we have 5 to the power of 0, and this is just equal to 1. Okay, so this is the type of sums that we can actually expect, or the level of complication that we can have. Now the first step actually is to now use prime factorization to get everybody to the same basis. Now if you have a Casio calculator, the way that you want to, the easy way to get a large number as a product of its prime factors is we type in the number, so we have 16, then you say equal, then you say shift and fact. Then you can see that 16 is now 2 to the power of 4. So that is what you do for each of these. Obviously, those larger number that's not a prime factor already. So the first thing I'm going to do is just the 4 and the 16, which is not prime factor. This one I just copy as it is. And then we have times by, now 4 becomes 2 squared. And then replace it in brackets. That's very, very important. Times by 2 over 2 to the power of 4 to the power of n. Okay, so that was the only the first step is only to replace the complex, not complex numbers, numbers that are not prime, to replace them as a product of prime numbers. And then we're going to use law 3 where we multiply in. So now we have 2 to the power of 2n minus 1 times by, now remember, very important is to multiply this 2 with both of these terms. So you have 2 to the power of 2n plus 2 multiplied by 2, and that's all over 2 to the power of 4n. Okay, and then the next step is now where we were with the previous example. We have all the same bases, so when the exponent is at the top you add it, and when the exponent is at the bottom you subtract it. So you have 2 to the power of 2n minus 1 plus 2n plus 2 plus, and this one is to the power of 1, so that's plus 1, and then minus 4n. And then we just simplify. So this gives us minus 1 plus 2 plus 1 is then going to be 2. So 2 to the power of 2 is then 4. Okay, next one. So once again, we start off by putting everybody in as factors of their products of their prime factors. So you have 2 to the power of 2n minus 1 times by 6 becomes 2 times 3. 2 times 3 to the power of negative n plus 1. And then times by 27 becomes 3 to the power of 3 to the power of n. And that's all over. Now 18 is 2 times 9, and 9 is 3 squared, so 2 times 3 squared to the power of n. And then we have the brackets. Now we can multiply in the exponents. So this is just still 2n minus 1, and then times, now this guy goes into both the bases. So 2 to the power of negative n plus 1 times by 3 to the power of negative n plus 1. And then times by 3 to the power of 3n, and that's all over 2 to the power of n times by 3 to the power of 2n. Alright, now we have all the bases. Now in this case we can see that there is a base of 2 and a base of 3. So we're going to group all the 2's together. And remember, when we have the exponents at the top, we add them. So we have 2n minus 1 minus n plus 1. So just add them as they are. And then subtract the bottom one, minus n. And then on this side, we've got 3 to the power of negative n plus 1 plus 3n minus 2n. And then we simply simplify. So 2n minus n is 0. Minus 1 plus 1, that's also 0. So you have 2 to the power of 0 here. And then for the 3, we have minus n minus 2n plus 3n. So this becomes minus 3n plus 3n is 0. And then we just have that 1 there. So that's to the power of 1. Then we have 1 times by 3. And that's just equal to 3. Right, and then for this one, start off again by prime factorizing. So that's 3 squared. Then we have to the power of x plus 1 times by 3 to the power of 3x minus 4. And that's over 3 to the power of 3. And then x plus 1. And then times by 3 to the power of x minus 2. All right, now let's multiply these exponents together. So I have 3 to the power of 2x plus 2 times by 3 to the power of 3x minus 4 over 3 to the power of 3x plus 3 and 3 to the power of x minus 2. Okay, now what's important here is, remember, we've got the base of 3 and we're adding the exponents at the top and subtracting the ones at the bottom. But now here we have 2 terms in the exponent. So always put brackets around them if you do have more than one term, because when you subtract them, then minus has to go to both of the terms. So 2x plus 2 plus 3x minus 4, that's just adding the top 2, and then subtract 3x plus 3 minus x minus 2. Okay, so for the following step, I'm just going to add these like terms along. That's 5x minus 2. And then just multiply in your brackets, minus 3x minus 3 and minus x plus 2. And then we just add those like terms. Here we have 5x minus 3 minus 1, that's just x. So x. And then minus 2 plus 2 over here, 0. So this is minus 3 that's left. All right, so that was then the lesson for today. Then you can start with the exercises.